And welcome back to another exciting day in mathematics. Warm-up 67's on the screen. Let's get started, please. Also, just a reminder for those of you that were absent on Friday, some of y'all need to make up a Pop-Tart tie. And there's some of you that actually need to retake that one. So Wednesday minimum day. How about tomorrow and Thursday during advisory or in the morning before we start? All right, so warm-up 67's on the screen. I'll give you some time for that. Copy and go. All right, let's get the show on the road just for the sake of time. As I mentioned today, we have a bunch of stuff to cover. Actually, we already did most of it. I'm just adding a couple more things. But it's one of those that you're going to be like, oh, snap. You guys use Snap anymore? No? Okay, I'm going to bring it back. Oh, snap. How about that? All right. Ready, Enrique? All right, here we go. Enrique says he's on like Donkey Kong. Here we go. Number one, complete the square. To complete the square, we add the middle term, just the coefficient divided by 2, squared. Is that correct? Therefore, this becomes x squared plus 14x plus, what is 14 divided by 2? That's 7. 7 squared is 49. Hands if you got that. All right, some of y'all. But then they're asking us to factor that. So 49, which is this, 14, which is that. What two numbers multiply give me 49 when you add them give us 14? That's 7 and 7. So my factors are x plus 7 times x plus 7. Or we can rewrite that as what? X plus 7 squared. So far so good, yes? Next, number 2. Rewrite this. Square root of 9 times square root of negative 1. Square root of 9 is 3. Square root of negative 1 is I. Plus minus, so plus minus 3i. Number 3, I don't know if you guys noticed, now I'm bringing in a lot of i's. You guys see that? Yeah? Because we're about to embark in this next section on complex numbers. So I'm going to start with addition. So we got I minus 5 plus I plus 2. So combine like terms. What is I plus I? 2i. What is negative 5 plus 2? Negative 3. However, who remembers what to do with this? Can we leave it like that? No, Mr. Q, the I goes at the end. All right, negative 3 plus 2i. This is my complex number. I goes at the end. I goes at the end. Mario, got that? All right. Let's go to subtraction. We got I minus 5 minus I plus 2. Remind your neighbor or see if they remember what to do with this kind of computation. What do we do? What's the first thing we do? Of course, Gio's got it. And Gio's thinking, oh, don't we distribute the negative? Yes, Mr. Q, we distribute the negative to both. So this is negative I minus 2. And then I combine with these. So what is I minus I? Cancel. What is negative 5 and negative 2? That's negative 7. So far so good, yes? Yes, Mr. Q, my favorite. Let's go to multiplication. What is I times I? I squared. What is I times 2? 2i. What is I times... Oh, my bad. I already did di. Negative 5. What is negative 5 times I? Negative 5i. What is negative 5 times 2? That's negative 10. So far so good? Combine like terms. I squared minus 3i minus 10. Am I done? No, Mr. Q, I think I remember something about I squared. Remind your neighbor What about I squared? See if they remember. What about I squared? You're like, oh my goodness, too much tamales and menudo and steaks and... We substitute what for I squared? Geo! -1, that is correct. You substitute -1 for I squared. Minus 3I minus 10, and then combine like terms. We start with the numbers by themselves. What is -1 and -10? That's -11, and bring down the -3I. Make a little asterisk here, a heart, to remind yourself to substitute a -1 anywhere you see I squared. Yes? All right, let's go with your favorite, division. You guys remember these? Yeah? All right, here we go. I minus 5 divided by I plus 2. All right, how many times, let's see. What number times I gives me I, everyone? Renzo? What number times I gives me 1I? 1, that is correct. All right, so 1 times I is I. 1 times 2 is 2. We're going to subtract, distribute. So that leaves us with -7 as a remainder. So our answer for this one, here it goes. The answer is what? 1 plus, what is my remainder? -7 over, what was our divisor? I plus 2. Yes? Now, did we rewrite those? Yes, I believe so, right? Do we leave the 1 in the front? No, we move it to the back, and we'll get to that later, just for the sake of time. Okay, let's go to number 4. Find the inverse. Change it to y. X plus 2 over 5. To get rid of the 5, what do? Multiply times 5, multiply times 5. 5y equals x plus 2. Last but not least, subtract 2, subtract 2. 5y minus 2 equals x. Am I done? No. Exchange the variables. So this is 5x minus 2 equals y. And then, of course, we change that to 5x minus 2 equals f inverse of x. Woo. Man, I love these. These are pretty good. How Mario? All right, so then, again, second one, change to y. 2/3 x minus 5. From there, we add 5, add 5. Y plus 5 equals 2/3 x. From there, we need to get rid of 2/3, so we multiply times the reciprocal, which is 3 over 2, both sides. 3 over 2. We're left with x equals, distribute, 3/2 y plus 3 times 5 is 15 over 2. From there, we exchange the variables. So we got 3/2 x plus 15 over 2 equals y, and therefore 3/2 x plus 15 over 2 equals f inverse of x. Woo! Too easy. Or should I say, what's the word? Too easy. All right? How we doing? Yes? So I gave you 2 different looks just to, bring it back, because we're about to get into that today, actually. All right, copy the agenda, please. Warm-up number 67. Today we're focusing on inverse functions. We're going to finish up with that section. And your home plate for tonight, only 2 pages, 53 and 54. They're going to be in the Nearpod code that I'm going to give you in a little bit. Copy the agenda, please. Please, code for your home play access, DJ53U. 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 All right? more than. All right, so with that said, get a Cornell note ready. Also, go grab yourself one set of graph paper, please. Go. All right, here we go. Our objective for today, I can identify and graph an inverse of a function. I can identify and graph an inverse of a function. Now, have we been covering inverses already for a while? Yes, Mr. Q? All right, because I was getting you to the point where we are going to be at today. Today's going to require for you to really focus on all the algebraic portions of the problem, okay? We've already did find inverses. We already graphed inverses, but today we're moving on to the next best thing, okay? So with that said, do we know what functions are? Yes, they are relations that have exactly one output for every input, and I gave you guys these examples, yes? So remind your neighbor, look up, why is this one not a function? Remind your neighbor, why is this one not a function? Talk it over your neighbor. Why is that not a function? Talk it over your neighbor, please. All right, looks like Enrique's got it. Enrique, why is this one not a function? The x has two outputs. It has a 3 and a what? And a 7. That is correct. That's why it's not a function. All right, so copy this on your notes, please. Example Q. Write that down, please. Identify the inverse of a function using a mapping diagram. Then you're going to write function. Then you're going to write inverse. So then let me give you the function first. Here's the domain. Here's the range. And then you map it. Show the mapping like this. All right? Here we go. So it says, identify the inverse of the function using a mapping diagram. We've used mapping diagrams before, is that correct? Which are these. So we're going to identify the inverse of the function. But before we do, I'm going to pass this one. Who haven't called on? Enrique's pointing to Sean. All right, Sean's going to enlighten us a little bit. So before I pass it to Sean, look up, please. I want you to think, and this is for yourself. Don't involve your neighbor. Look up. On the warm-up, we covered inverses, didn't we? Is that correct? Question. What made it the inverse? Think about that question. What makes that the inverse? What movement that we do makes it the inverse? All right, now talk it over to your neighbor. Tell them this is what makes it the inverse. What made it the inverse? It looks like Alessandra's got it. Very good, Alessandra. Edwin's got it. I see Edwin. All right. So now with that said, here's my original function. These are all my x values. These are all my y values because it's domain and range. So, also reminder, put away those cell phones. Pretty please. Sean, what would you say would be our new domain, being that it's going to be the inverse of the original function? What would you say? Ooh, from the corner. Hands, have you heard that? What did he say, Mario? What did he say the domain was of the inverse from over here? Which numbers? The range, that is correct. So let's see. So therefore, if this is the new domain, tell your neighbor what we're going to write for the range of the inverse. Everyone? The original domain, yes? There you go. Copy that, please. All right. That was example Q. Pretty straightforward, yes? So once again, just to double check, we said on the warm-up, I said, we got the inverses of the warm-up. And what is the one thing that we noticed? That what makes it the inverse when we do what, everyone? When we switch the variables, the x for the y. That's what makes it the inverse. So same thing with these mapping diagrams. If we are given these x's and these y, the inverse becomes, the range becomes the domain, and the domain becomes the range. Pretty clear? Yes? Sean, is that what you said? All right. So with that said, example omega q, write this down, please. And then find me the inverse of that function. I'm going to send you a screen so you can send me your work. You got 30 seconds. Go. So it looks like the majority of us got it. Here we go. So once again, for our new inverse, the domain was of the inverse is the range of the previous, and the other one is the original domain. Okay? From 1 to 5, I'll come to party with this. Okay, that's part 1 of the home plate. We good, right? Okay. Go to the second part. Get your graph paper in front of you and copy this one. Example super cube. And it says graph -4, -2, 0, -3, 1, 2, 4, 1. Then graph the inverse. From there, copy that question. What do you observe about the graphs of the function that it's inverse in relationship to the line y equals x? Copy that. I'll give you some time. All right, let me pause the music really quick and let me get your noodle ready. Y'all ready? Here it goes. I'm going to get your noodle ready for this one. So for this one, they're asking us to graph this, then to graph its inverse. So here goes some questions to get your noodle ready. Oh, not that one. All right. Question. Once again, what made these the inverse again? You already know. Is that correct? It always happens that I start recording and the fridge is almost like tearing apart over there. Did I tell you that I think somebody dropped it last summer? There's a little dent in the back, I guess, because they come in the summer, they clean all the carpets and the walls and stuff. So they moved all my stuff, they put it on top of over there. By the time I got here, it had like a big dent. So there you go, now it makes that noise. Anyways, what makes it the inverse when we switch what, everyone? When we switch the x and the y, is that correct? So, now that I got your noodle ready, here it goes. Let's graph this first, and I'm going to use blue for this one. Let's use blue for this one to graph this. So if you have your colors, use blue. -4, -2. 0, -3. 1, 2. 4, 1. Okay. But then I'm going to switch to red, and then they want me to graph the inverse of this. Think about it. What shall I write here to graph the inverse of that? Talk to your neighbor. What am I going to write here to graph the inverse of that? What do I write? What do I write? All right, check with your neighbor. They should know by now what to write there. Looks like Mariah's got it. Mariah, she's going to enlighten us a little bit. Tell your neighbor, what do we write here from the original function? All right, Mariah, what do I write? Tell me what you write. Parentheses what? Comma? Hands, have you got that? Tell your neighbor why Mariah gave us that, please, just to make sure that you understand it. Why did she give us those values? What did she do? What did she do? -2, -4. -3, 0. 2, 1. 1, 4. All right? And last, here goes. Let's answer this question. The question was, what do you observe about the graphs of the function and its inverse in relationship to the line y equals x? So let's graph this line y equals x. So I want you to sketch a line going through the center, point of origin, but diagonally, like so. So the blue points are the original function. The red points are the inverse function. So you know, neighbor, what you notice one to the other according to that line. What do you notice from one to the other according to that line? And we're going to have Mariah pass it to someone. Mariah, what do you notice? Pass someone. Caitlin, what do you notice? They are on the opposite sides. So look at this blue one. The inverse is over here. Look at this blue one. The inverse is over here. Look at this blue one and this blue one. So then just write opposite sides, or in other words, put in parentheses, reflection using the y equals x. Pretty good, yes? All right, send me your notes, please, on the screen. So, pretty straightforward, yes? So with that said, copy in the back of your graph paper, copy this one, example Kazan-Q. -39, -24, -1100, then graph the inverse and answer the question. You don't have to copy the entire question again, you already have it. Just answer the question just to make sure you see it. And go. All right, so far so good. Once again, if I was to ask for the inverse of these, who went last? Was it Caitlin? Pass someone, Caitlin. Go ahead, Kelly. Give us the new function. Uh-huh. And 0, 0. Hands if you got that. That is correct. From 1 to 5, how comfortable are you with this? Okay, that's the second part of the home plate. We good? All right, so now let's go to the funner part of the home plate. Y'all ready? Let's go back to our Cornell notes and copy this next one, please. Example, Michael Jordan Q. And it reads, find the inverse, that's step 1, for the given function f of x. But then it says, use composition to verify that the functions are inverses. That's going to be the doozy. So copy that. They give us a function f of x equals -3x plus 4, and I'll wait for you guys. Copy all that. All right, here we go. Part 1 of this problem says, find the inverse of the function. Do you guys know how to find the inverse of this? Yes. I'll give you a head start. Go. Find the inverse. All right, show your neighbor your inverse, please. See what they got. They should have the same thing as you. All right, and for the sake of processes, Enrique is going to walk us through this one. Enrique, what do I do first? The what? Switch the x. Very good. Change f of x to y. That is correct. Then what do I do, everyone? Leave x by itself, so I subtract 4, subtract 4. We got y minus 4 equals negative 3x. Next, divide by negative 3. Divide by negative 3. We're left with y minus 4 over negative 3 equals x. Is that the inverse? No, until we do what, everyone? Flip or switch the variables, yes? So therefore, x minus 4 over 3 equals to y. So, we need to change this to f inverse of x equals x minus 4 over 3. And for today's purpose, guys, for today, what we're going to do today, I want you to bring this over to this side, this whole thing, and this whole thing over to this side. So it's going to read f inverse of x equals x minus 4 over 3. Box that and write inverse. Inverse. Oh yeah, negative 3, sorry. For right now, let's leave it like that. So like that, that's only when we do the graphing. So negative and negative. Okay. From 1 to 5, I'll come to right up to right there. We got it, right? Okay. So at the beginning of the session, I said, stay focused. Because today, I'm telling you guys, this part is where I lose some of you. I don't know why. So I'm done with part 1 of the home plate. Do we know how to find inverses? Yes. But here's the doozy. Use composition to verify if the functions are inverses. What does that mean? Write in parentheses. Check. We're going to check if they are inverses. All right. So with that said, I'm going to write over here, check. So you need a lot of space because we're going to do some work right now. Okay, y'all ready? So to get started, I'm going to start with f of x. I want you to write f of x. We're going to get started with f of x. Now, how do we check, Mr. Q? Well, I'm going to take f of x, and at the end, it needs to equal to x. When I substitute, it's inverse. So that means here instead of x, I'm going to write f inverse of x. You're like, oh snap. Oh snap is right. I'm bringing that back. Are we there so far? Okay. So, in order for you to absorb this, writing utensils down, eyes up here. Here we go. I'll have you copy in a little bit. Here it goes. So, what do we need to have at the end? We need to have equal to x at the end. And what are we going to start with? F of x. So what is f of x, everyone? Oh, it's over here. F of x equals negative 3x plus 4. Are we there so far? Okay. However, before you copy, instead of x, what did I say we're going to substitute in here? What did we substitute? The inverse, yes? So I'm going to write f negative 3 plus 4. So watch. What did I substitute here? The inverse. So I write f inverse of x. So look, isn't this the inverse? Yes? So what did I just substitute? Oh, Mr. Q, you substituted this part. All right. So over here, instead of writing that again, what am I going to write? The other part, which is x minus 4 over negative 3. Copy that. So we said we're going to check f of x first, and what do? We substituted the inverse for x, and at the end we need to make sure it's equal to x. So what do? I wrote my f of x, substituted the inverse. So the left side, remember, the left side is only a label. I'm going to write this twice after that. I'm just going to write f inverse of x, f inverse of x. Do that yourself, please. And then we're going to do the right side together. Let me zoom in. Here we go. We need to distribute this 3 into the parentheses, yes? So here we go. Put the -3 over 1. Distribute -3 here and -3 here. And that gives us what? -3x. -3 times -4 is positive 12. Over 1 times -3 is -3. And at the end, plus 4. Next, let's simplify this. What is -3x divided by -3? And repeat that again. What is -3x divided by -3? 1x. What is 12 divided by -3? Okay, let's see if you see it. Here goes again. -3x divided by -3 is x, yes? And then we got 12 divided by -3 is -4. Yes? All right, bring down the plus 4. And let's simplify the last step. Here it goes. F, when we substitute the inverse, what happened? What is -4 plus 4? They cancel, yes? And that leaves us with x. We're still not done. Here we go. So we're done up to right here by checking this, yes? Well, now we need to do the other way. Look up. Now we're going to start with f inverse of x. Write that down, please. So that means we're going to write f inverse of parentheses, and at the end we need to find x. But now we're going to substitute the original f of x in there. So, read me the inverse, Joseph. What was the inverse? F inverse of x equals, hold on, x minus 4 over, and then goes here for x, f of x, and over here, -3x plus 4. That is correct. I'll stop right there. Just finish it off, and at the end, you need to end up equal to x. Jesus, really quick. I'm not going to be here during Festo. Do the home plate, guys. Get some practice in. It's at the beginning of that code I gave you guys. See you guys next time. Bye.